Hello everyone, good afternoon, and then salam alaikum. Welcome to the second lab for the week. Um, so today we're going to be working on lab 8. Am I audible enough, guys? Am I audible to you guys? Can you hear me from your side?
Yes,
Yes,
sir.
sir.
Okay. So today we're going to be working on lab 8, and then basically I believe you all have the lab materials with you. So as you can see from the lab material, lab 8 is about decision trees, right? It's about the use of implementing decision trees in Python. So without wasting time, I'm going to share my screen with you, and then we're going to look at the implementation in Python together in Colab. Okay, so yeah, in the past we have actually looked at a couple of machine learning algorithms. We started with simple linear regression, then we look at multiple linear regression. We also look at the use of logistic regression, right, for classification and for regression. And we look at naive Bayes. And I think last week we look at support vector machine and key nearest neighbor. And then we discussed the intuition behind support vector machine and then key nearest neighbor. And remember, support vector machine, you have hyperplanes, in addition to decide the best fit line, support vector machine use hyperplanes, right? And then for key nearest neighbor is based on the nearest samples of points to each of the data points. Okay, so and then we see that these algorithms can be used for both classification and for regression. The same thing applies to decision tree also. Decision tree is a machine learning algorithm that can be used for classification as well as for regression. It's actually based on, the partitioning of the attributes into trees. You use something like tree-like structure to section your data. For instance, let's take sample the one of these data we have been working on, the Titanic data set. We want to use decision tree for training the Titanic data set. What decision tree will do is that it will basically split your data into something like, okay, let me work with the sex. So for the sex, it will look at the sex attribute and then consider that how many male survive and how many female survive. So based on on that number, it will put it into decision trees. That, okay, for male that survive, I have maybe 100 survive, 120 survive. Then for the 100 males that survive, what class are the survived passengers? Is it the top class or the middle class? So if you put that one too into branches, so if you keep on, putting all your data set into different branches up till it comes to the last node. Actually, we have about 3 types of node. We have the root node, which is the first node, and then we have the decision trees, and then we have the leaf node. We're going to look at that, but then let's just look at so basically for this lab, we want to look at the implementation of trees for regression and classification. So for the regression, we are going to be working on the eta dataset, right? And then the ETA data set is collection of sample records of baseball players. So we have baseball players. They have collected some records about the baseball players, and then the attribute collected includes something like the number of hits, the number of home runs, the number of years, and then the salary. So I think salary is the target in this case. So what we want to do basically with this data set is we want to use those attributes to see if we can predict the salary of a baseball players. We have so many attributes, like as I mentioned earlier, the number of years, and then the number of hits, number of runs, and all of that. Okay, so that's that for ETA data set. And then for the classification, we want to work on the Titanic data set. And then, yeah, I don't need to really talk much about this because we've worked with Titanic dataset in the past. So then the last one, which you're going to do, is to use classification for the ETA dataset that we work on initially using regression. Okay, so this is just a high-end overview of our tasks for this lab. So it's going to be a very short class. So because most of the concepts we are used to them already, right? By now we are used to the importing of your packages, importing of your machine learning algorithms, and then the partitioning of your data into training and testing data set. So it will be faster, and then it will be in the next couple of minutes, or few minutes we should be done. Okay, so let's begin. So the first thing is we want to import the necessary packages. I think I have a message or something. Okay, so we want to import the necessary packages, and as usual, we will always work with pandas and be numpy. So we'll just import that. Okay, so that one is so the next thing is that we want to work with decision tree, so we have to import it. So there are actually a couple of ways you can do your importing of your algorithms. The first is just to import the what's it called, the top package where you have the models inside. So for instance, if we use from sklearn import tree, this is the top package. So inside this package, we now have the two types of decision trees, which are the decision tree regressor and the decision tree classifier. So if we use these, right, if we use from sklearn import tree, that means when we want to call the regressor or the classifier, we have to now use the method, tree.decision tree class regressor. So let's use this from sklearn import tree. Just like we saw for support vector machine, right? Inside support vector machine package, we have SVC and we have SVR, which is the support vector classifier and the support vector regressor. Okay, so we have imported the decision trees. Then for our assessment, for accuracy assessment of our model, we want to import the metrics. So we import the metrics, right? So we want to read our data, and our data is in CSV. I've downloaded the data, so I'm just going to import my data to my session storage here so that I can access it. So you all know how to do that, so I'm just going to quickly go over that. So upload, and then you can mount your drive also. You can actually mount your drive, and where is that? So this is it. It has, okay, I have it here. So you see it coming here. So this is the data set, right? This is the data rather. So I'm using read_CSV method of pandas. to read my data. Now I want to look at my data, see how my data looks like. So you can see here, this is my data set. We have 322 samples, which is the rows, and then 20 columns, right? So these 20 columns, we have about 19 attributes or features and 1 target, right? So depending on, but for this case, right, we are working on regression. So our salary is the target. So the rest are going to be the attribute, right? So so one of the things that you have to do, in almost all machine learning situations, you want to like do some pre-processing on your data. And one of the pre-processing tasks is to, find out if your data has some missing values or if your data has some outliers, and then you have to, address these things. And then some other ones is that depending on your algorithm, you want to maybe standardize your data, the scale of your data, So here, what we are doing is to check for missing values. So to do that, we call this is null method, right, on our data frame, and then we then later now call the any. So what do you want to say that if there is any value, right, that is null, that's the interpretation for this line of code. So if there is any value here that is null, so you should let us know. So if I run that now, you can see we have the return to be true. That is saying that yes, at least one value in your data frame is null. So what do we do next? We have to address this missing values situation. There are a couple of ways to do that. A very simple, all of them are simple actually, but this one is most likely the first one you want to think about, which is like you want to just remove the null values. You want to just remove any record that has missing values, because it's going to affect your work. But this one has some limitation. It has some demerit, which is the fact that imagine in a data set, you have about 70% of the records having missing values. You cannot remove 70% of your record, especially for data set that you don't have much of that samples. Like in this data where you have 321 or 322 records now. Now how do we find out the number of the number of records that has missing values? We can use the same line of code here, but instead of calling any, we just say sum. So now, what this one is saying is that for each, take the record and keep on adding them. If I have one record with missing value, make it 1, and if you see the next record with missing value, add 1 to it. So keep summing. So sum all the records that have missing value. So from here we can see that 59 records out of 322 has missing values. So if we want to use the drop, the approach that I was talking about earlier, that you can just drop all the records that have missing values. By dropping, I mean you can just remove them. So what that one is doing is that out of these 322 records that you have here, 59 of them will be removed. And those 59 are those 59 records that have missing values, So removing 59 from 322 is still going to have about 200 and something. And then, yeah, maybe that's still okay for you to train your model. So I think the drop any will work here. But in situation where okay, so what we did here basically again is that we just call the data frame, right? And then I call the drop NA method, right, on my data frame. So, and then you can see if you read the, what's it called, the guide, it tells you that the drop NA remove missing values. So you're going to remove all your missing values, I mean the records, the rows, because by default, the axis is equals to 0. But if you want to remove the column, you can set the axis to be 1, right? So you can either remove the rows or the columns, which has missing values. For instance, if in your data set you see that maybe the what's it called, this assist is not, most of the records for the assist is not there, it's missing. So you can just drop the assist instead of dropping all the samples or the rows that has missing values for assist. You can drop just one column and then continue with your thing. So in this case, we drop the records. So what we can now, you can confirm now, the new data frame now has 263 records, right? You can see 263 rows, whereas initially the we have 322 records initially before the drop NA. Okay. So what we want to do is we want to now, select our attributes and target variables. So for this purpose, for this work, for this task, we are going to use just two independent variables, which are the it and the years, right? So you can check it here. This is the it, and then this is the years, right? And then the target is just, the salary, since we are working on the regression. So just call that. And then, okay, so before I move further, I mentioned about some other ways you can address the missing values. Instead of dropping your NA, you can use what we call imputation, right? You can just like use the mean, right? Maybe for this case now, you can just find the mean or median of a particular attribute and then use impute mean. So that means any record that has missing values, you are going to replace the null values with the mean or something. There are so many of them, but that one is another way around it. Okay, so here now, we want to partition our data set into the training and the testing data. Okay, so to do that, we just want to use slicing. We want to use indexing, right? We can also use this what's it called, train test split method. You can use train test split method, but here we are just using indexing, slicing. So that means we call x train to be our x, right, and our x, right. I'm just going to show you x so you know what x it looks like. Right, this is our x. So you can see the x is the data frame of the two independent variables that we want to use for the model training, which are the it and the years, and then the y is the this is now the series of this salary column. Okay, so we call x train to be this x, but from the first record to the 132nd record. So that means the first 132 rows, right? We didn't put any number here because it's starting from the first. And then the y train is also going to be the corresponding length of the x train, and then the y text is going to be from the 132 to the last record. So we want to take the rest of the data for testing, and then the y also. Okay, so we can just print that and see what like. So you can see the training dimension is 132 by 2, right? And then this is for the x and this is for the y, 132 by 1. So 131 for the training, and then for the this should be the testing. It should be the testing. Okay, so we have training to be here, the testing to be here. Okay, so now let's continue with our model. Let's now get to the main task of model building. So what we do is, remember, we have import the decision trees, right? So we can just call our tree dot, and see, we have inside the tree, we have the decision tree classifier, like I told you, and we have the regressor. But now I want to use the regressor. So we just call the tree.regressor. Actually, for the decision tree, we have some, parameters that we have to set, right? We have like the criterion and all of that based on the concept of the tree partitioning. But then for the first instance here, we are just using the default parameters. So we are not putting anything there. Just want to run this. So we have initiated our decision algorithm now. So we want to train our model. So you can read more about decision trees here. The decision tree regressor. You can read more about it here. So subsequently, I will be calling decision tree DT. So, to fit your model, you just call the fit method on your model, and then you pass the two parameters, the X twin and the Y twin. So I'll just run this. So our model has been fitted, and we have it right. So by default, these are the parameters. The criterion is MSC, the maximum depth is none. That means keep on splitting until you are satisfied. Okay, so we just select some attributes, the attribute that we use. Now what we want to do basically is we want to look at what is this decision tree regressor doing basically. So we want to plot the sample, a sample decision tree for this task. So that's why we use matplotlib, and then we specify the size of the plot. Now, to plot the decision tree, we have what's called plot_tree method, right? So if you call that plot_tree method on our model, and then we pass on our model, which is the regressor, right? We call it regressor here. So we pass that regressor on in as the parameter for the plot_tree method. Is going to plot the decision tree for our model. So we're going to see how that one is working. This is just a kind of schematic something. So this is basically how it's working. This is the working principle. We can see we have the root tree here, and it now start dividing it into different branches, right? We will call this one decision trees, and until we get to the last one, which is called the leaf node. So from here now, if you want to make decision with this decision tree, let's say you have what's it called? I want to check the parameters, the number of eats and the number of years, right? Let's say you have eat to be like greater than 120 and the number of years to be greater than 15. It will just start checking for the decision trees here. Okay, this is the eat. Okay, when eat is greater than 1, maybe 50 here, we have years, you have the salary. Now when it is greater than 100, you have it to come here and here. Then when it is not greater than the main one you specify, it comes here. Then when the number of years is this, so it just keep going, and then going and selecting the right branch that align with the one you want to predict based on this decision tree that it has created. So that's how the decision tree works basically, right? So you can compare that one with the one on support vector machines, which use hyperplanes, and then the k nearest neighbor that use a particular number of neighbors to make decision. This one use decision trees for its what's it called, decision, right? So we can look at it. What can we can try to check the performance of our model. So to do that, remember we import metrics when we started. So we can just use that metrics or you can just start importing again from sklearn.metrics, import mean square error, right? So this one will find the mean square error of our predictions. So what we now do is we actually make prediction with our model, and you know, to make prediction you have to just pass in the independent variables that you want to make predictions for, and in this case we want to make prediction for the x-text, so we just pass in that x-text as our parameter for our predict method, and then we have our y-predict stored here. So to now assess our model, you know, this is an out of sample assessment because we are now assessing on the test data set. So to assess our model, we just call the mean square error matrix, and then we pass the y-test, which is like the y-test. Remember, the y-test is they are the real values, and then the y-predict are the predicted values, right? And you know, the mean square error is just basically the sum of squares of the residuals. So it will just subtract the y-test from the y-predict and then they square it and then find the mean. So we can find this, and then you can go further to find this root mean square error, which is going to be the square root of the mean square error. Now you can print it now. So that's the score. That's our performance. Our MSE is 530. Okay. So now let's look at another. Let's tweak our data, our machine learning model a little bit. Here now, what we want to do, remember initially when we first use decision tree here, we just use default parameter, right? And then for the default parameter, you can check, you can see that the default parameter, there is no maximum, what is it called? There is no maximum depth. Max depth is none by default. No maximum depth. What that means is that keep on splitting the data. I mean, keep on splitting the tree until you are satisfied. That's why you have so many, I mean, branches like this. You can see this is so many, right? This can lead to the kind of overfitting of your data set. But then we want to now change that. Now here, we are using what we call a prune tree. So pruning means that you want to, you know, cut off or specify a limit for your decision trees. Don't go to any depth. Just have 3 depths and then make decision or make prediction based on that number of depths, right? So here now we just call decision tree regressor. We now pass maximum depth to be 3. Since alpha is 2, so let's see what that has. So, oh my, decision tree regressor is not defined. Okay. Okay, so what this one is saying is that we have not defined this. So what we will have to do, and the reason is because, remember, I told you at the beginning of this lab that there are 2 ways you can, you know, import your decision tree. Is that you just use the import the upper or the I model, the I module, and then now call the method on it, or you import the required, the specific model. So here we got this error because we actually imported 3, but we are calling decision tree regressor. So what we can do here is we can just say from sklearn.tree import decision tree regressor, right? So if you run this now, we have imported the model. Now let's run it again. So we have that one now. So we have initiated our model. So now we want to pass our model now. I mean, fit our model and our data. So we just call the fit method on our model. We pass the 2 parameters, x train and the y train, to fit our model. So you can see the max depth is the number we specified. So we want to plot this decision tree now and compare with the one we have earlier. So just use plot_tree method of the decision tree. Now you can see that we have very less branches now compared to what we had initially, right? Where we have so many branches here. Now here we have just about, 3 branches, right? 1, 2, 3, right? 1, 2, 3, 1, 2, 3. So this is a pruning approach to your decision tree. Now, the same way as we did, we can assess the performance of our model here too. So here we have lesser, what is it called? We have lesser error, which mean square error is 424.012, 012, compared to the one we had here, which is 530, right? So this is a way to, improve the performance of your model, right? You have to specify the maximum depth. So the question that comes to mind now is that what should be the maximum depth? I can just make this one to be 5. Is it going to be better, right? So we're going to look at that. We're going to try to answer that question in next few minutes. We get there. Okay. So this is how you implement DT, decision tree, on your machine learning task for regression, right? So before we move to the next task, which is the implementation of decision tree for classification, I would like to pause here and find out if you guys have questions. So do you have questions before we move on what we have done so far? Do you have any question on that?
Sir, actually,
Okay.
right. I'm confused about how do we differentiate between regression tree and classification tree? Like what is the purpose of us doing regression or classification tree?
Okay, so you see, it's still the same. The answer to that, it still goes down to the main principle of regression and classification. If your target is a numerical data, right, it means you are doing regression task, right? And you can see that in this case, we have our target. Our target, y now, which is the dependent variable. Our target, we specify our target to be salary, right? And if you check your data set, you're going to see that salary is a numerical data format, right? You have 475, 480, 500, and all of that. So this is a regression. So you have to use decision tree regressor now because you are working on regression problem. But in the next one that we want to look at, we are working on what's it called, titanic dataset. We want to use decision tree for titanic dataset. And in titanic dataset, we have worked with the titanic dataset in a couple of labs, and you know that what we are doing in titanic dataset basically is just to predict on the survivor of a passenger, right? So is either the passenger survive or not. So this is a classification task. That's why you are using decision tree classifier in this case. So another way you can know is that the outcome of a decision tree classification is a class. It is going to put your prediction into classes, right? But then the outcome of decision tree regressor is in form of numerical format like this, 4.2, 4.8. This is not a class. This is a number, right? So this is this is the model performance. But you can check the the Y predict values here. You can check the Y predict values. Y predict. So you can see this is your Y predict, and then you have it in form of numerical something, 90 point something, continuous record or continuous format. So does that answer your question? Do you get that?
Yes, yes, sir.
Okay. Okay, so any other question before we move on? Anybody with any question? Okay, so in the absence of questions, we move on to the next, which is to implement decision tree for classification. Okay, so we don't need to do this because we have imported the packages initially. So what we just need to do is to now import the decision tree classifier now, because we know we want to do classification. But in this task, instead of, although you can still use the, what's it called, the indexing, you can still use the, I want to show you what I mean. In this initial, the first example that we saw, when we wanted to split our data into training and testing, we use slicing here, right? We use indexing here. But that this one is, you have to be putting the numbers and be sure that it might actually take some time or something. It doesn't take time anyways, but I think it's better to use this approach now that we want to use here, which is the train test split method. So what we do is just basically to import the train test split package, right, from model selection. This one is actually inside model selection, right? When you import that, we can use it later. Just take note that we imported train test split package. So now we want to import the metrics, right? Now here we want to now read our data set. So to do that, I'm just going to load my data set to my session. Titanic, where is that? Titanic, please. Okay, so we have it here, titanic.csv. So we can now run this. So let's see what this one looks like. So you are used to this before. So this is the Titanic records. We have 714 records here. So let's check if we have missing values. So we don't have any missing values here, false. Okay, so we can continue. Okay, so one of the pre-processing tasks we need to do, especially for data set that has some attributes in form of classes. Like for instance, this sex, I think we did this in one of the labs where we have sex to be male and female. In this case, you have to construct a kind of what's it called, approach, or a kind of way to make your machine learning model understand these classes. You have male, female. So what we can do, sorry for this, I need to work on the Windows license. Okay, so what we can do is that we can just put this one is kind of, if the person is male, put it as 0. If it is female, make it 1. So that's basically what we did here. So this is to undo the categorical data of our sex attributes. So what we did was basically to create another column. So we call df2 msex, because when you are calling a data frame with a name and the name is not part of the existing columns, what it is going to do is going to add that new name into your data frame. So we have df2 msex to be equals to 0 or 1. What we are doing here is a condition, and I think I explained this. So what I am doing basically is that we say np.where. This is a condition. The condition is that anywhere your sex column, df2 column sex, is equals to male, then make the value to be equals to 0. Otherwise, make it to be equals to 1, right? So, and this is sex column. So anywhere it is male, it is going to put 1, right? Anywhere it is female, it's going to put 0. Anywhere it is male, it is going to put, where is that line? Anywhere it is male, it's going to put 0, and anywhere it is 1 is going to put, anywhere it's female is going to put 1. So we can see that. So you can see now male is 0 and female is 1. So you have that. And then we want to now specify our predictors and our target variables. So in this case, we have our predictors to be all the columns except the survive, which is going to be the target. So we just say, yeah, predictors x equals to df2 of p class mcx a this, right? And then y equals to df2 of survive, right? This survive. So now to split our data into training and testing now, we are calling the train test split method that we have imported. So if you read that, you can see that what it says is that this method or this module is going to split your arrays or matrices into random train and test subsets, right? So what we need to do is we now have to specify what is the size of our test data, or you can specify what is the size of your train data. So if you specify the size of 1, automatically it's going to know that the complement to that or the remaining record is going to be your size for the order. For instance, if you say text size is 0.5, then train size is going to be 1 minus 0.5, that's 0.5 also. But if your test size is 0.3, then your train size is going to be 0.7, right? I want to be sure that this test size should be 0.5. Let me check. Because I think because 50%, it's really strange to use 50% for your test. Okay, that's it. It's 0.5. Okay. So now we are not going to have, remember we passed x and y. What it's doing is that for x, it's going to split it into x train, x test. For y, it's going to split it into y train, y test. So that's why we store all those things in x train, x test, y train, y test consecutively. Okay, so we just, oh my, did I use this? No. No. I didn't want the initial something. Oh, I know. No, this is not what I want. I didn't run this first one, so I have to run this one first. Because remember, x is still stored as the initial x we were using, so I need to run this one. Okay. So let me just confirm y. Okay, now. So when we do that, I can now run my x train and then, train test split now. So you can just confirm x train. So your x train is 357 by 6 columns, right? And then remember x is 714. So 357 is half of 714 data set, records or rows. Now let's call our decision2 classifier. Just call that. Then we fit our data set. To fit, just call the fit method on your model and pass the training and the x train and the y train, the attribute and the target. Then we now want to plot our trees now. Okay, so we have this is our tree, you see, so many branches. So let's predict with our model. So we have our y predict. Let's check our model performance. That's the accuracy of our model. So this is 0.71, which is fair. Okay, so now one thing we want to do next is we want to, remember when we call the DT classifier, we use default parameters. because we didn't pass any arguments. Where is it? Yeah, we left it empty, so it used default parameters. So now we want to find out how many branches should we have, and then what is going to be the entropy of our data. So to do that, we can use what's called grid search CV, right? We use grid search, that's called parameter optimization. We want to find the optimal parameters for our machine learning model, because we can just pass 2 as the depth of our decision tree, or we pass 3 or 4 or something. But we don't want to be passing one by one. We want to just check which of these range of values of maximum depth of the decision tree is going to give the best performance. So that's, the grid search is about, from the name, it implies it is going to be searching for, using each of those parameters, you supply them, and then be checking their accuracy. Which one is the best is going to give you your result. Okay. So for the criterion, we want to check between Gini and entropy. You see, this criterion is, you see, this criterion is a method for splitting your data set. Because if you go and explore on the concept of decision tree, you see, decision tree works on what is called purity of classification. I don't want to go too deep. What I mean by purity is that when I'm classifying when I'm making, what is it called? Where is I think I have time. I can just make some explanation. Okay, now when I'm doing the branching of my data, of my decision tree here, there's something we call purity. Purity is that when this one is, let's say, we have sex here, male, female. But then in our data records, we have like 100 females survive, and then 150 females, 100 females survive, 20 did not survive. Now here you have survive is 100, not survive is 20. Then in another record you have female. For female you have that 100 females they survive. Then none of the female did not survive. In this case, you have your purity for female. That means you can be sure that, I think, yeah, female, they have a kind of purity decision because 100 of them, all of them survive. So when you want to make decision with female now, you have some level of purity because you know that all of the female instances in my data set, I have that they survive, right? So that purity there is 1. So this is a sense of this is actually an idea, a concept of purity. But your decision tree can assess purity based on some method or some approaches. One of them is Gini, one of them is entropy. So what we want to do here is we want to find out which of these two is best for assessing the purity of our decision tree. So anyways, just pass in your criterion, Gini or entropy, and for the max depth, I explained this, you can pass 2 to 11, right? So, you have to import grid search CV, then specify because your grid search CV, you'll be passing your parameter, and then you have to pass your accuracy method, and your cross validation is 6. You pass 6 to the cross validation. So now we have specified our parameters that we want to test. Then we now run grid search CV. What's the problem? Name grid underscore parameter is not defined. We define this now. Grid underscore parameter. Okay, so we have that. So now we want to fit our grid search on our data set. That means, learn from the data set to find out which of these parameters is most optimal for our model training. So it's actually learning now. From here, we have our grid search object created. Now, from our grid search object, we can find the best parameters. So what we do is just call the best parameters method on the grid search object. So it's going to return that, okay, the criteria that is optimal is Guinea, and the max depth should be 2, So it selected this as the best criteria, and then it selected 2 as the maximum depth to use. So now we know that when we want to train our model, this should be the parameters to use. So we can find the score of our grid search. So it has 8.2, I mean 0.8 rather. So now let's create the decision tree classifier object using the best or the optimal parameters. So we just call the decision tree classifier. For the criterion, we pass Guinea, and the max depth we pass the 2. So we now want to fit our model on our data set. So we just call the fit method on your model, and then you pass the independent and the dependent variables. All right. Now we want to plot our decision tree now. Remember, we use max depth of 2. Let's see what that looks like. So you can see this is your decision tree for this problem now. You have just 2 branches, and for those 2 branches, it use sex and it use age in your attribute. So it use sex and age, right? So this is what it's basically using for your classification. So you can read more about that from this. If you just type plot tree on Google decision tree, you are going to go to scikit-learn. Scikit-learn is a very, because that's where the right documentation is. You see a lot of examples and the correct documentation on any machine learning package that you're looking for. Okay, so let's see the model assessment. So when you use the accuracy score here, we have 0.77. I think this is better than what we had initially, which is 0.71 or something. Yeah, 0.71. So we have 0.77. So with this, we are able to demonstrate how to use. Okay, so what the third one is for you to define. You want to use decision tree again for a classification problem. Remember, for this ETA data set, this one, we use decision tree for the regression. Now here we want to use decision tree for classification on the same data set. Now, just as somebody asked earlier, that now we want to use another decision tree package, which is the classification for the same data set. What is going to change here is that we are now going to have targets, that is classes, or in classes, not a continuous data format. Our target for this one now is going to be in classes. Now, how do we do that? Remember, our salary is our target. Now, what we want to do here is you now want to put your salary into 2 classes, which is the high and the low salary class. So now it's left for you to now determine the boundary mark for your salary. So you can determine maybe 1,000, depending on this thing. So you can maybe you can choose the median, and then anyone below the median is your low salary, and anyone above is the high salary. So that means in this case now we have converted that problem into a classification problem, and then you are just going to use decision tree classifier on that data set for your machine learning building. Okay, so with this, we've come to the end of the lab for this week, for this second lab. So this is all we have, basically just a kind of recall. We implemented decision tree on regression problem by using the ETA data set, and then on classification problem by using the Titanic data set. So you have to, try the classification task again using this same ETA dataset, but in this case now, you want to turn your target. You want to turn your target into into classes, high and low salary classes. So this is the end of today's lab demonstration. If you guys have any problem, or I mean, if you have any question rather, you can let me know.
No questions, sir.
Okay, so in the absence of questions,
Sir.
Yes.
Can I ask that, right? So for the part 3, that the classification done on the heater dataset, can you show us the code to determine high and low salary?
To determine high and low.
Yeah.
Oh.
Like how do we change the high salary, the number into high salary, and the other set of number into low salary?
Okay. Well, there are two ways you can do it. The first way is you can use Excel basically to do the classification. Like just from your Excel, you have your CSV data. Open your CSV data in Excel, and then I think you can sort your values. I mean, you can sort your record by. I'm trying to look at how you can do it in Excel. You can sort this salary based on ascending order now, based on order. So I mean, it will sort it in ascending order. Then you just look at the middle records, which is going to be like 150 something, or you can. So that 150 something is going to be like the median. Then you just type low for the first, I mean, the upper records above the median, then the one below the median should be high. I mean, the one above the median should be, I mean, you should understand my explanation for the Excel approach, right? The concept is that you want to group your data into high and low, your salary. Now, if you want to now use Python, there's a way you can use it, Python. Now, for instance, if you want to use Python for this case, what you need to do is just have another record now. You can say, this is my DF. You can just say, you can create another record, DF column salary class equals, let's say, DF salary. Now I'm going to use np where now. np dot where. I'm just going to, I told you that you can use like let's just copy the np where. Where is that np where for this for the sex? We're going to just so that you see a way to use np where. Just use something similar to this np where. Where is the thing I was typing now? Okay, yeah. So you just tweak this np where, right? You just np where df now, df of what? df of salary. Where anywhere df of salary is less than df of salary mean. Salary dot mean. I'm not sure if I can get dot mean here, but let's try. Anywhere, I don't know if I'm not. It's less than df of salary dot mean. Make it to be. If it is less than the mean, make it to be low. I'm using mean now. Otherwise, make it to be high. Okay. Most likely, it's going to be. Let me see if this one is going to work. I'm just going to comment this out. Let's run this. Okay, so I think that works. Okay, so let me just say df now and say Ouch. DF. Which one is my DF? Okay, 293. Okay, let's see. Now you see now I have my salary class now. I have my salary class added. So I have my I, low, low, low. You know, it and you can see that the I salary values are the ones that, you know, they are high. You can see they are high, except for any N. But what you can do is that maybe you can drop any N first, because what we are doing, do you know why this one that does not have any salary also have I? Is because what our condition here is that np.where df salary is less than mean, let it be low. Then any other one should be high. That means even if it does not have salary, put it high. So what you want to do is you want to drop your missing value first before you now call this thing, right? So let me run this thing again. Run that again, and then no, instead of even use that, I will just use 1 and 0 here. I will just use 0 and 1. I think that one will be better. So I'm going to drop that. Then now I can now call this thing again now. df2. Then I'll just put it here. I'll call that. So I'll just put, if it is low, let it be 0. And if it is this, let it be 1, right? So I'll just call this one df low, maybe low I, or let's say I salary class. I salary class. What this one is saying is that if the salary is low, then the value is 0. If it is high, then the value is 1. That means it's high. If you see 1, that means it's high. If you see low, that means it's, I mean, I'm not sure if you guys get what I'm trying to do here. Okay, so basically you have it now. You have 1. I thought I dropped any N. Anyways, you have 1, you have 0, you have 1, you have 0 here. So 1 basically indicates your I salary, and you can see when you have 91.5 or something, you have your low salary range. So I think 500 is the mean. You can find the mean of this column, salary column, to know that you are doing the right thing. Let me just find the mean. To find the mean, you just do this, df of mean. So it's 535. 535 is the mean. So anything below 535 is low. Anything above is high. I think that should answer your question. Does it?
Yes,
Does
sir.
that answer?
Thank you.
Okay, good. Okay, so any other question?
No, sir.
Okay, so in the absence of question, I pass the floor to Mr. Naim.
Yes, thank you, Mr. Nahim.
You're welcome, sir.
Okay, so if there is no more questions, so we can dismiss our class.
Okay, sir, can.
Okay, thank you. Thank you, everyone.
Thank you,
Stay
sir.
safe.
See you guys later.